In this video, we'll look at the force between charged particles, which is called the electrostatic force. See static right there? That's like static electricity, isn't it? Sure. To see, so here we have this negative is going to be attracted there, isn't it? What's going to happen is the force is going to go that way. Here, these are repelling, aren't they? The force is that way. Alright, it says here, two things affect electrostatic force between two charged particles. The amount of charge and the distance between the charges. Now we'll look at that more closely in these next slides. Now here's your classic electrostatic force diagram, and you'll see this probably a couple times in the MCAS. The particles are circles. If you look at your MCAS formula sheet, you'll find that little q is the symbol for charge. So this means a positive 1, doesn't it? We don't usually write the 1, that's implied. So this is a positive 1 charge. And over here, that's a negative 1 charge. See? So they'll put the charges inside the circles. Now this is an attractive force, isn't it? Because the negative is attracted to the positive. Right. Okay, so we have charges there, and then up top here we have the distance. The line between the center of that one, labeled usually by D or 2D, that kind of thing, will be the distance. So charges down here and distance there. Classic electrostatic diagram. Now let's start here. And this changed two things. First we'll change the charge, then we'll change the distance. And then I want to use common sense. I want you to use common sense to say where is the charge greater or less. Pardon me, where is the force greater or less. So we'll start here, positive 1, negative 1, and D. Change the charge. What changed here? That one did not change, did it? Did that one change? Sure. It went from negative Q to negative 2Q. So what do you think? How will the force change? Won't there be more attraction here? Sure. More charge, more force. Makes sense, doesn't it? Now this bottom leg, what are we changing here? Changing the distance. Note the charges didn't change. 1Q and 2Q, positive and negative. Look what happened to distance. It doubled, didn't it? It went from D to 2D. Now use that common sense again. What do you think? If you have two charges, they're attracting each other, but you put them further apart, that'll decrease the force, won't it? It's common sense. More charge increases force. More distance reduces force, doesn't it? So let's see here. Let's try to write down who has a higher force here. Let's look at the first one here. We'll start here, over here, okay? And what are we changing? We're changing that to negative 2Q. Isn't this more force here? It is. We have more charge, more force. So let's say B then is larger than A. Makes sense? In terms of force, more charge. Now we'll go down here. We'll start here and go down here and change the distance. We doubled that, didn't we? Did our charges change? No, they didn't. Further apart down here. Doesn't that mean less force? Sure it does. That means the force here, A, is larger than B. Let's put these together. Does this come out to B is larger than A? Then A is larger than B, right? Wait a minute, I made some mistake here. Oh, should be C here, shouldn't it? Sorry about that. A and C. Good. Sorry about that. B larger than A and A is larger than C. Alright, so our greatest force is going to be in B, isn't it? More charge, same distance. Our least is going to be down here. We have same charges but greater distance. And then A ends up in the middle, doesn't it? Okay? Right. So I'm going to wrap it up here and just say this. There are two things that affect electrostatic force. The first is the charges, right? If you go more charge, like we did here, and by the way, these two repel, don't they? They're positive charges. More charge, more force, right? If I go this way, less charge, less force. The second thing is distance. If I go from here to here, don't change the charges, but I do change the distance, I double it. Distance, more, it's less force, isn't it? They're further apart. If I go back this way and make them closer together, then we have less distance, but we have more force, okay? I got about 30 seconds, so to repeat myself here. Charges. More charge, more force. Less charge, less force. Distance. More distance, less force, the further away. Less distance, more force.